Welcome back to Data to Crunch. If you are new here, this is the part of series, so I would recommend you to start from part 1. Link is in the description box below. If you are continuing from last video, let's get straight into it. Let's start with our data governance part. So in this section, we will first create one email notification integration and then we will set one pipeline health alert. So let's start with setting up our environment. So for this, we will be using role account admin. Then our database would be dev database and warehouse would be our pipeline warehouse. I'll run these queries. This is completed. Now our first step is to create email notification integration. And with this step, we will be able to connect with our email server. To create our notification integration, we will say create notification integration. If not exist, and then we will give name of our integration. So let's say that would be email notification int. Then we need to mention type of our integration. In our case, it would be email. Then we will say enabled is true. And we will mention one comment as email notification integration for pipeline health alerts. And then we will run this query. So it has been set. Now let's say if you would like to check if your notification integration is working as expected or not. So for that, you can test it by calling one stored procedure which is given by Snowflake by default, and that stored procedure name is send email. So we can test one email by calling that stored procedure. So to call that, we will say call system $, then send email is the name of that procedure. And in this, we will mention few details. First detail would be of your integration name. In our case, it is email notification int. Then you need to mention email address on which you would like to trigger that test email. Then you need to mention subject of your email. And lastly, you need to mention text body of your email. This is just for the testing purpose. End it by semicolon. And before this, you need to do one thing. You need to call this start user email verification, which is again given by Snowflake. And here you need to mention your account name. So you will get your account name. If you'll go to Snowsite, under your account ID, you can see this name. You need to mention it over here. And first we will run this. Now it says that check your email address for verification of email. Now go back to your email address, Gmail account. And now it states that validate your email. Click on this validate your email. It states that your email verification has been verified. Now we can close this window. Coming back to our Snowflake, now we will call this send email procedure. We will run this query now. It says true. That means this has triggered one email on our email address. Then again, we will go back to our Gmail account. Then if you will see here, we have gotten one email. Click on that. It is coming as expected. We can see the subject of our email coming as expected, and this one was our body text. This means that our notification integration is working as expected. Now coming back to our Snowflake, let's say you want to verify whatever integrations you have created. Then to check that, you can say show integrations. Run this. It will show you all the integrations which you have under this Snowflake account. And our notification integration name was this one, email notification INT. So this one we have created just now. Then the next step is to create our pipeline health alert. So to create that alert, first we will say create or replace alert. We can set this alert in any schema. For in this scenario, let's say we will configure this under bronze schema. You can do it under gold too. We will say pipeline health alert. This would be the name of our alert. Then we need to mention our warehouse. In our case, it would be our pipeline warehouse. Then we can schedule it at the interval of 5 minutes. Now we will write the main part of this alert where we will set our notifications. So first we will say if exists. Then in this part, first we will check for bronze Snowpipe failure. Okay. If our Snowpipe that fails, then also we will trigger one notification. So for this, we will write query as select one, then from table, and here we will refer our information schema table. And then we will check our copy history. In this, we need to mention our table name first. So we will say table name is equal to, and our table name is raw orders. Then we need to specify start time. Our start time would be last 1 hour. So to set that, we will say date add hour last 1 hour from the current timestamp. And here we will check our where condition, where status is equal to load failed. Now we will have union all. This one was our first failure alert. Then our next failure alert would be on silver task failure. It will check if our bronze to silver task or silver to star task failed in last 1 hour or not. For that, again we'll say select one from table, and for this we will refer our task history table from information schema. Here we will add our scheduled time range start. Again, we will check for last 1 hour. And we will mention our where condition, where state is equal to failed and database name we will mention. Mention your database name here. So for development, our database name is Flowbridge DevDB. So this integration or verification would be for silver layer task failure. Now, the next verification we will do for gold layer dynamic tables failure. In this scenario, we will check if any gold dynamic table has failed or not within last 5 minutes. So for that, again we will write select one from table. For this we will use dynamic table refresh history table, which is again under information schema. So let's query that information schema dot dynamic table refresh history. We will write our where condition for this, where schema name is our gold schema, then and condition with database name, our development database name, we will mention it here. Again, and condition, status would be failed, and refresh start time, we will mention it here. That needs to be greater than last 5 minutes. So for that we will use date add. Now it would be for minutes, last 5 minutes from the current timestamp. So this is how we will perform verification for 3 failures, one from bronze, one from silver, and another one from gold schema. Now we will set our action here. So if these conditions get satisfied, then or one of these conditions gets satisfied, then we will call our system email. Again, our integration name, that is email notification int. Then our email address. Then we need to mention subject of our email. We will say pipeline alert. Flowbridge project. And then we will mention text of our body. So let's say here we will say something went wrong in the pipeline. Check bronze, silver, gold layers for failures. Log into Snowsite. Check monitoring. In that, check task history or copy history. And then we will end it with semicolon. So we are telling them to navigate to this one, log into Snowsite. Then we have this monitoring, and under monitoring we have this query history. We are telling them to check here what has failure at that time. Okay, so this is how they will get the status of failed, and they can click on that and check what has exactly happened or what has gone wrong in their pipeline. Now let's run this. Let's check what's the error. Okay, so the database names which we gave, it needs to be in inverted commas. So I think it has done changes for that. So we will say keep all, and again we will run this. So alert has been successfully created. Now once you are done with creation, you need to activate your alert. So for that, what we will say, alter alert, mention your alert name. Now this alert is under bronze schema, so I'll say bronze schema and then pipeline health alert, and then we are going to resume it. I'll run this query. If in case you would like to verify if your alert is active or not, for that what we will say, show alerts in database and then mention your database name. So this is how you can see your alert. And now state is started. That means this alert is active. Let's say if you'd like to check alert history, then for that we have one table under information schema, and that table name is alert history. You can query that too. Select star from table and then mention your table name. It is alert schema dot, sorry, information schema dot alert history. And in that, you will mention your scheduled time range start. So we will check for last 1 hour. We will say scheduled time range start, which is equal to date add. We will check for last 1 hour from current timestamp. And then we can use order by to here. We will order by scheduled time in descending mode. And we can limit also here. We can use limit. Let's say we will use limit 10. And we will run this query. So here you need to mention greater than sign and then run this. So here you can see your alert history from this alert history table. So let's now in the third step, let's verify your governance objects. So again, we have seen that if you'd like to check all the alerts, then we can say show alerts in database and then mention your database name. We have seen this earlier just now. And then if you'd like to check whatever resource monitors are there, which we have created in the first account setup, then for that you can say show resource monitors. And now these are the monitors, resource monitors, which we have. So this is how this governance part is completed. Now let's push this change to our GitHub. Coming back to changes section, we will push this. We will write one comment here. We'll say pipeline health alert set or setup. Click on push button. Now we will switch back to our Git account. We will compare and pull request. Change your base to dev. Create pull request. Merge pull request and confirm merge. So this is completed. Now we will come back to our Snowflake. Here we will switch back to our dev branch. Now we will create new feature branch. So that would be our 9th feature branch. New feature 9. And here we are going to promote all our code from dev to prod. Okay. So for that we will say dev to prod. Here we will perform cloning part. Let's first create branch for this from dev branch. Click on create. Make sure your new branch has been selected here. Coming back to files. Now we will create one new SQL file here. Name for that would be, let's say dev to prod. Now in this section, we will promote our dev environment to prod environment using Snowflake's zero copying cloning. And here also we will check which objects are allowed to copy directly and then which objects cannot be cloned. Okay, for example, Snowpipe, streams, tasks, and alerts, those can't be cloned. So we need to recreate it for our production environment. But rest of the things, rest of the objects like tables, views, dynamic tables, stages, file formats, sequences, those are allowed to copy using our Snowflake feature, which is zero copy cloning. Okay, so now let's start writing code for this. Now let's start promoting our objects from dev environment to production. And we are going to do this using Snowflake's zero copy cloning. So what does this mean? Traditionally, if you want to move your data from dev to prod, you would have to recreate everything from scratch. All your tables, then reloading your data, rerunning your transformations. So all this is very time consuming, error prone and risky. But with Snowflake's zero copy clone, it's very instant. No data gets physically copied and there is no extra storage cost at the time of cloning. So you get exact replica of dev and your dev environment completely remains untouched. So it's like taking a snapshot. But there is one catch. Not everything can be cloned. Okay. Tables, views, dynamic tables, stages, file formats, sequences, all of those can be cloned perfectly fine. But when it comes to Snowpipe, streams, tasks, and alerts, we cannot simply clone these. Okay. Why? Because we have external dependencies for these objects. For example, our Snowpipe is tied to Azure Event Grid subscription that points to our dev container. If we simply clone it, Azure doesn't know to send the notifications to our new pipe. Same with the streams, their change tracking offset is meaningless on our clone tables. And tasks and alerts, their reference specific database path that needs to point to our production objects. So our approach here is very simple. We will clone what we can and we will recreate what we can't. So with correct production configuration, we are going to recreate some of these objects. Now let's start step by step. For this, we need to make sure that our role is account admin. Then we need to clone our bronze schema first. For that, we will write it as create or replace schema. Now we will refer our bronze schema from production environment. So that would be Flowbridge prod db bronze schema. Then we will use clone keyword and we will clone bronze schema from dev environment. We will run this. Let's verify this from our Snow site. If we'll refresh this. So this is how our dev bronze schema looks like, and this is how our prod bronze schema looks like. If we'll check tables, then we have raw orders table cloned as expected. And our data, we had 300 rows into our bronze schema under this raw orders that also gotten copied as expected. Then stage, it is also there. File format is there. Pipe, this pipe is also there, but again this pipe is referencing to our dev container. Now we will need to recreate another pipe that will refer to our prod container. Okay, so now coming back to our Snowflake, we will clone our silver schema and gold schema. Now we will do necessary changes. We have serving schema 2. Here make sure that it is silver schema. Here it needs to be gold schema. And then serving schema. Now run these cloning of schemas. It will take some time to clone everything because we have some objects into each of the schema. Now it's completed. If you'd like to verify all the schemas from this database, you can simply say show schemas in database and database name. Run this. Now we can see all the schemas which are there under this prod database. Now we need to grant our ownership of prod schemas to sysadmin. As of now, if you have seen, whatever we have done, we have done it using account admin. Now we need to grant ownerships to sysadmin. So to do that, we will say grant ownership on schema and then mention schema name, to role sysadmin, And we will just say copy current grants. And again, similarly, we will do it for rest of the schemas. Just make sure that you are assigning proper schemas here. Now run these queries. In the next step, we will verify all of our rows counts, whether they are matching with dev environment or not. For that, first make sure to select role sysadmin, because just now we have granted all the ownerships. So now in the next step, we will verify if our row counts matches with dev environment or not. For that, we need to make sure that we are selecting sysadmin role. Then we will check few tables for this, and those tables would be raw orders from bronze, then SDG orders and packed orders from silver, and then aggregation base from gold. So these counts needs to be matched, because just now we have cloned our tables which were there under schemas, and those schemas we just cloned from dev to prod. Now quickly run this. Okay, let's run one by one. Now we can see we have, as expected, 300 records after cloning from dev. Then next is for SDG orders. 263 records, all data has been copied or cloned as expected. Let's check packed orders now. Again, the count is correct. And then aggregation base. Again, we have correct count. That means that whatever we have cloned, that has worked as expected. Now in this scenario, we would have needed to recreate our storage integration for production. But if you remember, in the bronze layer, when we created this storage integration, under this allowed location, we have mentioned both of our locations, one for dev and one for production. Hence, we don't need to recreate our storage location for production, and we can go ahead with the same storage integration. If in case you would have created this storage integration, which is just pointing to this dev container, then in this scenario, make sure that you are recreating this storage integration with new name, and that is pointing to our prod container. So in this case, it is not needed. We can just verify our storage integration. For that, what we can do, we can say describe integration and then mention your integration name, which is Flowbridge ADLS integration. Let's run this. This is another way to verify. If you'll come here and we'll check storage allowed location, just double click on this property value. And here you can see both of our value, one for dev and another one for production. Hence, recreation is not needed here. Now we need to recreate our Snowpipe, because we need to point our Snowpipe to our production container. Okay, whatever Snowpipe we have just now, that is pointing to our dev environment. Now for this, make sure that you are using sysadmin role. Our database is production one, schema is bronze, and warehouse is our pipeline warehouse. Run this. Now we will be creating external stage for production. So coming back to bronze, we'll search here with stage. If you see here, we have created stage like this for development. Similarly, we will create stage for production, and just we will give another name for that. Okay. Coming back to dev to prod, I'll just paste this code here. Now we will change the name here. We will just add production into it and make sure that this URL is pointing to correct container. Our integration would remain same. File format also we can keep the same. And here add comment, and we are going to list down this external schema, external stage. Okay. Now let's run this and create this external stage first to check our files here. Now it's said that we have no data produced because in this production container we don't have any data. Okay. So coming back to our storage accounts in ADLS in Azure, if we'll check here, containers production, we don't have any data into it. Okay. So here what we can do under VS Code, we can run our historical mode for production. Just run this command. Now it has uploaded 3 files there. Now we have these 3 files under our prod container. Now moving back to our Snowflake snow site. If we will check here, under stages, we have now this new stage, okay, which is under prod DB, and that is raw ADLS stage prod. We will enable the directory table. Now we can see we have these 3 files. Just verify it. So those are 896, 701 and 425. 896, 701 and 425. Now we can see that we have our files under this external stage, which is for production. But if you remember, we have cloned the tables from development database to production database, okay? And those tables have already data present, which got cloned from dev to production. And we can see it here. Now, what we are doing, now we are just copying data from production container. We need to make sure that, or we need to keep in mind that our data will get appended in these raw orders. Okay. So now if this raw orders has 300 data, then when we create our pipe, that pipe will append 300 more records from this production stage into this raw orders under this production DB. Okay. So your data will start running from 600, or you will have 600 data into your table, and then your pipe or your data pipeline for production will work on those 600 records. You can go ahead with this approach, or else you can do one thing. You can truncate all the values or all the tables from this production database, and you can verify your pipeline for these 300 records which we are going to insert or which we have under this external stage of production. You can do either or. So what we will do now, we will truncate. I'll go ahead with second approach of truncating the tables. Okay. So instead of writing all the code, what I'll do, I'll take help of Cortex code, and I can give a command as, can you truncate all the tables from Flowbridge prod DB to check new data from this stage. Make sure that you are saying truncate here and not drop. If you say drop, then it will drop all of your tables. We are just saying truncate so that all the values in that tables, those will get truncated. And instead of writing all the values, we are just taking help of Cortex code to truncate our tables, okay? So you just need to say allow. It will start truncating your tables. It will give you one by one. It will also mention the tables which this is truncating. Okay, so it is saying that it has truncated these tables, but you cannot truncate dynamic tables because they can't be truncated directly, but will refresh automatically once new data flows into these dynamic tables. Okay, so far so good. Or else we can say, can you refresh these dynamic tables so that I can work on new data in prod DB. Now it will give you, or it will alter our dynamic tables which are in production database, and it will state refresh. Okay, so this refresh is nothing but truncate only, but for dynamic tables you can't use truncate, you have to use refresh. Okay, say allow. Again, next, for the next dynamic table, second, third, and the last one. I hope it is last. Okay, so all of our tables are refreshed. It has cleared all of our old data that was there, and those were these entries. So it has deleted all those entries. So now we have 0 entries in all of our production databases tables. Okay, we have created this new stage which is pointing to our prod container, which has now these 3 tables. Now let's see if it is listing values or not. 896, 701, and 425. Okay, this means that this stage has now our new data. Okay, now let's grant system admin usage. Now we need to grant our sysadmin to notification integration. Okay, I think it's not needed. This is also not needed. We will create our prod Snowpipe now. Okay, for that, again I'll come back to bronze. I'll search for pipe. This is what we need to copy, and we need to make necessary changes. So coming back to dev to prod, paste this. And here make sure that you are pointing to you are giving new name to your pipe, then auto-ingest true. Integration, this is fine. Copy from bronze orders. Here again we will mention our database name, that is not necessary, but again to be on safer side, we will mention it. We will copy this data from, again here we will mention our database name. Okay, now this pipe will, and here make sure that we are now pointing to our production stage. So this is how our recreation of Snowpipe would look like. Create pipe, again this will be our new pipe with auto ingestion true. We are going to copy into our raw orders table which is under this production database, and we are going to copy from production stage. Let's run this. It states that this pipe has been created successfully. Now refresh this. Now we can see that now under this production database we have these 2 pipes. This one we have created for our production purpose, and this one it got cloned from dev environment, but This is not needed for our production environment. Okay, so even though it got cloned while we cloned our schema, it is not necessary for production environment as of now. So what we can do, we can drop this pipe. For that, what we will say, we'll say drop pipe, and then we will copy that pipe name. So that one was under production database, bronze schema. We will click on here and then we will say place name in the editor, semicolon, and we will run this. It is successfully dropped. Now let's refresh it. Now we can see that we have only one pipe that is for production. So far so good. Now let's say you want to check the status of your pipe. Then for that you can have this select query, which will say select system pipe status and then mention that respective pipe name and run that query. After running, you can check execution state, that is running. This means that this pipe is currently running. Now the next step is to recreate our streams for production. We'll need to recreate our two streams, one for raw orders and another one for stage orders. So let's quickly write that code, create or replace stream. This one would be under silver schema. And then raw order stream. If we'll check our silver stage 1, this stream which we are creating, okay, so we can copy paste it from here also. And now this one would be on our production raw orders table. And then we will create another stream on STG orders. That one was probably under stage 2. This one we need to use. We'll just paste it here. We'll mention database name. And here it would be on table STG orders. Now we will run these queries. These streams has been created successfully. We can verify it also. We'll say show streams in database and then database name. We have two streams now under our production database. Now we need to recreate our stored procedure for production. And this would be our we will need to recreate both of these procedures which we have created. So the one was from bronze to silver. And this one was under silver stage 1. We will just copy it from here. Coming back to dev to production, we will paste it here. And here we need to make sure that we are changing the required databases and schemas name. So here, create or replace procedure. We can mention our database too. It needs to be under silver schema. Then here we will create our temporary table under this production silver schema. Select star from production database. Insert into, we will have dead letter table under production database. Then we have this select query from this temporary table. Then we have part 2 for STG orders. Again, we will mention our production database here. Then from, again, temporary table from production. And then drop table. Here again, we will mention our database. And then we will run our query. So this is created successfully. Now we will create our another stored procedure. Which one was for, and that one, I think that one was silver to star. You will get it under silver stage 2. This one, we'll just copy it from here. We'll paste it into dev to prod SQL file. And again, we will make sure that we are doing required changes. So we will create it under production database, create or replace table, make one change here, select from, another change here, merge into, one more change here, from this table, again we have merge, from, add it here, then again add it over here in the fourth merge, select from, then for dim warehouse add properly, again into merge into, and then from. Similarly for dim shipment, and then for packed orders, and then lastly here for drop table if exist, production database. Then run this stored procedure. Now we need to, in the next step, we need to recreate tasks. One for bronze to silver and another one for silver to star. Again, coming back to silver stage 1, we will copy creation of our bronze to silver task. We will paste it into our file. Again here, we will make necessary changes. We will run this query. And now another task that you would get under stage 2. This task. So here in the first task, when stream has data, here also mention your database name. And then we will run this task again, the first task. Again, coming back to silver to star, mention databases at 2 points, and then create this task again. Now to verify our task, we can simply say show tasks in and database name. It will show you both of the tasks which we have created just now. Now we need to recreate our alerts for production. For this, we need to switch our role to account admin. Then we have created our health pipeline alert under governance. So I'll open that file again, governance one, and this pipeline, this alert of health pipeline, we'll copy and we will paste it here. Here again, we will create it under production database. Here we need to change database name to prod. Here also change. Here we need to refer raw orders only. And then we will create our alert. Our alert has been recreated successfully. Now we will resume our alert. So we will say alter alert, mention your alert name, and we'll say resume. Now the next step is to create our share, okay? For that, again, we will need to use account admin role. So we will say use role, account admin. Then first we will create our share. To create share, we will say create share. If not exist or create or replace share, we can say. And our share name would be supply, let's say Flowbridge. Prod share. We can add comment. We will say Flowbridge share for serving views. We will run this. Share has been created successfully. Now we will grant usage for this production, okay? For that, we will say grant usage on database to share and then share name. Run this query. Now similarly grant it on schema. And we will grant on our serving schema. Run this query. Now we will grant select on our respective views, okay? For that we will say grant select on view. Those views are under serving layer. So our first view is view order fulfillment. Again, to share and share name. Similarly, we will grant select on rest of the three views. After view order fulfillment, we have view supplier performance. Then we have view inventory turnover, and then we have view shipment delays. And now we will run all these queries all together. Now to verify share, you can simply say describe share and then your share name. It will show you all the access which we have granted now. Database, schema, and then 4 views. And to verify grants, we can say show grants on share and then share name. It will show you the grant for that respective share along with ownership and name. Again, the next is to create reader account. So if you remember, we have 3 logistic partners and they need reader account access, right? So that whatever views we have created or whatever updated values which we will get under these views, those will be accessible to them, but they will be only able to see those tables and will not see any SQL query which we have used to create those views. Okay, now we will create one reader account that will be our managed account. So to create that, we will need admin name and admin password, which we can set from here. So let's say you will set first reader admin name. I'll say Flowbridge admin and then set reader admin password. Set your admin password in this inverted comma. Then we are going to say create managed account. If not exist, I'll give my managed account name as Flowbridge partner account. Here admin name would be this variable, then admin password would be this password. I'll say type, this would be reader type. We can add comment, reader account for Flowbridge logistics partners. Access to fraud KPIs only. Now you set your respective password in these inverted commas and then run all these queries, okay? And then it will create your managed account. So I'll set my password quickly and I'll run this. I have created my managed account successfully. It's just that you need to mention $sign in front of this admin name and admin password. Now we will get our reader account details. So we will say show managed account. Now we can see that this is account name which we have created. For this, you need to click on this account locator URL. But before that, you need to do one thing. So this is our account locator, okay? We need to set this account locator to our account. For that, what we will do, we will say alter share. Our share name was this one. And then we will say add accounts. And into double inverted, we need to mention this account locator value. Semicolon and then run this. It has been done successfully. Again, we will run this show managed accounts. Then click on this account URL. I created this managed account and then assigned this locator to my managed account. And within few seconds, I have tried to go through this account URL and that was getting failed. I was getting error as file not found. So you have to wait for 3 to 4 minutes and then try to navigate to this account URL. Now you can see this is how logistic partner will be able to see his reader account. Here he needs to add that username and password which we have set for this managed account. So our admin name was this one. We will enter it here as username and then add your password which you have set for that account. So I'll add mine password. And click on sign in. So this is how that logistic partners will see their accounts. Okay. Here we'll see Flowbridge admin is the name of our this Snowflake account. Now think from logistic partners perspective. So this is their account. They need to check data sharing option from Horizon Catalog. Click on this data sharing option. Now you can see here this share which we have created just now into our dev2 prod SQL. That share as direct shares that will be given to your logistic partner. Then that partner needs to click here to get that data. So once you click on here, you will need to mention database name and which role you would like to have along with sysadmin. So here you can give database name as, let's say, Flowbridge prod share, and along with sysadmin I'll say account admin, and we'll say get data. Now our database has been created. Let's click on view database. Now if you'll see here, we have two schemas. This one is serving schema and another one is information schema, which is by default given by Snowflake. Under serving schema, we have views. We can check these views, 4 views, which we have given access to. Okay, now it states that it has no warehouse available. For this, you will need to create one warehouse and then you will be able to access that view. Okay. So for that, let's say we'll create one worksheet. And here we have no warehouse. So first we will say create warehouse. Flow bridge, reader warehouse. Run this. It has been created. We will assign that warehouse here. Now we don't have anything under procedures. I don't know why it is showing here. Views, less name in the editor. Now I'll say select star from and then run this query. Now under this reader schema, if we are reading any one of the view, we are not getting any value because in the developer account, when we created, particularly when we recreated our stored procedures and tasks for our production database, after recreation, we didn't resume it. So that's why we don't have any data present into our tables, into this developer account. That's why reader account is not able to fetch any one of the value for these views. So for that, we will first need to call our procedure. Let's call both of our procedures. Now for this, we will grant ownership on stream with sysadmin role. Now make sure that your role is sysadmin and then call your both stored procedures. And then we will alter our tasks. Now, once we are done with call procedure and alter task, make sure to alter dynamic tables too, which we have forgotten. And then we will run this query to verify what are the entries in each one of the table under production database. We'll see here. Now, we have these values. Under raw orders, we have 300. Then under dim customer, we have 6, product 6, shipment, we have 263, supplier warehouse. So we are getting values as expected, we can say, in the table. Now coming back to our reader account, let's run this query again. Now you can see that we are able to see all the data. Now let's do count star here. We have 15 entries under inventory turnover. Same, we will check it here. Let's do count star here. Here also we are getting 15 entries. That means whatever updates we are performing into our developer account, those are getting reflected correctly into logistic partners reader account. Now we are done with this dev to production promotion. We will push this code to Git and then we will make one last file which will be resume and verify. Now let's go to changes. click on push. Then we will say dev to production promotion completed. We'll click on push. It is successful. Now we'll go to our Git account. We will click on compare and pull request. Change your base branch. Create pull request. Merge. Confirm merge. So this is completed. Now coming back to our Snowflake account. This reader account, we are done with this as of now. So I'll just close this. Now we will create one last file. Before that, we will create another feature branch. So switch back to dev. Then we will make another feature branch, which would be feature 10. We'll say resume and verify. Create. Now coming back to files, we will add our last SQL file. We will name it as resume and verify. Here we are going to write all of our code and select queries so that whenever you will come back to this project, you don't need to go through each one of these files and resume and recreate everything. You will just come back to this 9th file. Here we will write all of our code to alter our tasks and alter dynamic tables, whatever is there. You will simply run this file, which will resume all of our tasks, and it will start running our pipeline. And to cross verify, we will write one select query using union all, where we will be able to see all the table values. Now let's say under the production container, we have started ingesting our files continuously. Then once you ingest your files into this production container, we will just come back to this SQL file, as we have already resumed everything, right, in this file. Then once ingestion starts, we will come back to this file and we will just query that select query. Okay, and we will just keep an eye on all the tables, and we will check if their entries are getting updated correctly or not. So at the end, first we will resume everything from this file, and then we will start ingesting data. Accordingly, we will check our select query if that query is getting updated correctly or not, or our tables are getting updated correctly or not. Along with that, now we will create one Streamlit app also. According to table values which we are getting here, we need to verify if our app values are getting updated correctly or not. Okay. So this is how we will keep verifying once we start ingesting our data into production container. So for that sake, we are making this one final file. For that, let's start with our code. First, we will say use role. Make sure we are using sysadmin role, and then use warehouse, which would be our pipeline warehouse. Run these queries. Next, as of now, we are going to set everything for production environment. If you want, you can set it for dev environment too. It's up to you. So right now, I'll just set for production one. So let's start with resuming pipe first. First, we will resume our pipe. For that, we will say alter pipe. flow bridge prod DB. That pipe is under bronze schema, and the name for that is this one, pipe prod. And we will set pipe execution paused equal to false. Run this. We are setting this to we are setting this variable pipe execution paused is equal to false because we can't resume pipes. Okay, so if you say alter pipe name set and then resume or refresh, that is not going to work. That is not the correct syntax. To correct this is the correct syntax where you can alter pipe. For that you need to set this flag as false. If you will set this as true, your pipe will be paused. Then we will verify our status of pipe. For that we will say system pipe status, and then we will mention our pipe name. See here execution state is running. So this one was our first step where we have resumed our pipe. Now next step would be to resume our tasks. So to resume task, we have just written the code here. I'll just copy this from here and we'll paste it in this file. I'll run these tasks. We can check our tasks by saying show tasks in database production database name. Now the next step was to resume our alerts. For that we need to use account admin role. So switch back to account admin. Then we will say alter alert. Our alert is into bronze schema and our alert name is pipeline health alert. And we will resume it. It is done. Again, to check all the alerts, we can say show alerts in database and database name. Alerts. Okay, so now we can see that we have one alert. Next would be resume our dynamic table. Again, we are going to use sysadmin role. Switch back to your sysadmin role. We have 5 dynamic tables. So we just now written code for that. I'll just copy that from dev to prod file into this last file. And then we will run these queries. Now our last step is to verify row counts. So this is how we will verify our row counts. We are selecting and checking count in each of the table with union all. So let's run this query. So here it is showing data as of now for the 300 records for that 3 files which we have inserted in historical mode under production. So for that, this is the count. Okay, this one was basically our first run for our production. And to check values into our respective views, we have just written select star from and that respective view. So this is how first when we will work on this project, first we will resume everything which is before this, and then we will start ingesting our data at this step. And once we start ingesting data, then we will keep an eye on these queries, okay? Select queries. So right now, these are 300 entries, okay? So I have ingested one file of 100 records. Then we'll see if this raw orders value if it is getting changed to 400 or not. And accordingly, or rest of the table values, STG orders, then shipment value, packed orders value. These values need to be changed accordingly. So we will just keep an eye on these value entries and how they are changing. Along with that, we will also check our secure views, how they are getting updated. And with these two select queries, we are going to verify our Streamlit app also, okay? Now first we will push this code to our Git and then we will start working on our Streamlit app. Changes, push. We will add one comment here. We got success message. Now moving back to our Git account. Compare and pull request. Switch to dev. Create pull request. Merge pull request. Confirm merge. And it is done. Now switch back to our Snowflake. So what we will do, I'll just duplicate this and then we'll navigate to Streamlit via this projects, okay? Projects and then Streamlit. We will click on Streamlit app. It will add these files. We'll see the files which are required to create this Streamlit app here, okay? Now, so this is demo code which is given by Snowflake. So if you run this, you will get this output, okay? So this is just for demo purpose. Now what we will do, we'll just remove all this code and we will start writing code for our Streamlit app. As of now, we can close these two. This is our Streamlit app.py file. We have YML and plus TOML file too. Here, now let's start writing our code in Python for this Streamlit app. First, we will import pandas libraries. We'll say import pandas as PD. Then we will import Streamlit libraries. Import Streamlit as ST. Then we will import datetime. From datetime, we will import datetime. And along with that, let's import time delta too. Then we need to get active session. So to import that, we will use from snowflake.snowpark.context import get active session. and we will assign one variable session is equal to, and we will work on our current active session. We will use our database, and our database name would be Flowbridge prod db, and then title of our project would be, or app would be, we will give it as st.title, and we will mention title name here. Our title name, let's say Flowbridge dashboard. First, let's run this code as of now. Run. Now you can see this is how our as of now code looks like into our app. Okay, now we will give one button here to refresh our app. So to give that, we can say if st.button, and here we will mention our button name, refresh data. Then we will clear our cache data. Okay, let's say clear cache data, clear. Run this. So we have added one button here as refresh data. So what is, or what will happen here? This app, it will take some time to load our or to update those respective charts according to the updated values. But let's say till then you don't want to wait. Okay, so simply click on this refresh data button, and then that refresh data button will clear your cache and it will give you updated values. Okay, so for that sake we are adding this refresh button. Now let's add one divider here, line divider. So we'll say st line divider. Run this and we'll check how it comes. So this is how our divider has gotten added. Next, we will have two columns first. Okay, in those two columns we will give two filters. Okay, so for that, what we'll say, column, our first variable name would be call filter 1, and then call filter 2, and we will have st dot two columns. So with first column, we'll say with call filter 1 colon, we will give date options or date type with radio button. Okay, st dot radio, and those buttons, first we will say filter by, and then we will give two buttons. Okay, so comma, and two radio button names. First name would be order date, comma, second one would be ingestion date. And we will say here we need these two buttons as horizontal. Okay, for that we will say horizontal equal to true. Now let's run this app till this. So if you'll see here, for column 1, call filter 1, first column, this is our basically first column. We have two radio buttons. For that we have given st.radio. This filter by is this one, this text value, and then we have two radio buttons as as order date and ingestion date. So we can switch in between these two buttons. Okay, now this one was for first column. Now let's write code for second column, and variable for that is with call filter 2 colon, again we will give date options. Under date options we will provide one array. First value would be today, then we will give another value as let's say this week. Then third value as last 7 days. Then we'll say last 14 days. Then we'll have last 30 days. Then last 90 days. Year to date. Then last year. And then we'll say all time. And along with that, we can give custom range too, if needed or not. Then we'll say selected period. And for this, we are going to give select box, which is under st. Or then we'll say select st dot select box. Here we will mention as time period. This would be our text, comma. Then select box option will have these date options, and our index would be 2. Now let's run our app till this. So this column filter 1 and filter 2 we had for 2 columns. So these are our 2 columns. First is this column and second one is this column. First we have given radio button. For second time period we have given this select box. So this is how our app is functioning as of now. Now let's start writing the code for each of these selections. To write that, first we will check our today's date from date time. We will get today's date for calculating our ranges. Then we will use if-else statements. Okay, so if selected period is equal to today, then our start date would be today. And end date also will be today. Then we will have else if selected period is equal to this week, it needs to be equal to this week. This week as in Monday to today, okay? Then again we will have start date and end date. Our start date, it will get changed, and that would be, we will use time delta function here. Time delta days today dot weekday. So this will give you Monday to till date for this current week, okay? Then we will have else if again, and then for this our selected period right now would be last 7 days. If we have last 7 days, then our end date will be today only, but start date would be, again we will use time delta function. And here we will mention days is equal to 7. So this will give you last 7 days data. Then our next period is last 14 days. For this, we will just change this time delta value to 14. This one we will change to 14. Similarly, if now we have 30 and 90, okay, so we will paste this twice. Last 30 days and last 90 days. And these days would be changed to 30 and 90. Then we have YTD. For that, again, if our period is year to date, then again our end date would be today only. We'll need to change our start date. For that, we'll say today dot, we will use replace. Month is first month, and then day 1. So it will give you value from January 1st of this year to till today. Then we have period of last year. Again, I'll copy this. Now our selected period is this one. For this, again, end date would be today. Start date would be, it would be today minus, we will use time delta function of days 365. Then for all time we will write last else statement where we have no data restriction. So here our start date would be none and end date would be none. Now again, as of now we are done with this logic of selecting each of these checkboxes. Next, we will gather all of our statuses. So we will use variable as all statuses. And we have statuses as first status is pending. Then we have processing. Then we have shipped. Then we have in transit. Then we have delivered. Then we have cancelled. Then we will club all of our regions as all regions. We have 3 regions. One is North America. Then we have Europe. And then we have Asia Pacific. Now we will have one more 2 columns, and we will assign variables for those as column filter 3 and column filter 4. And for this again, similarly, we will have 2 columns assigned. st.columns, and then we'll have 2 columns. Then we will write first logic for column 3. Okay, so with column filter 3, this column, it would come below this filter by on the left hand side. Okay, and this column we would put on order statuses, selection of order statuses. So for that, we'll say, again for this we will use select box. Okay, for that we'll say status box st dot select box. Under select box we will say text, we will give one text as order status, and then we will mention all. So this all value from that respective drop down, that would be our default value. Okay, so for that we are mentioning this all as default value like this, plus we need to have these all statuses. Our index would be 0, and then our key would be status mode. Now if status mode is equal to all, if all is selected, then we need to include every status. Okay, so for that we will say if status is all, then select selected statuses is equal to all statuses. It will give you full list. It will not give you full list, it will use full list. And then we will have else statement. If that logistic partner, if that person adds any specific status, then we need to allow adding more values into it. Okay, so for that else we'll say extra statuses. Again we will use streamlit st, and we will have multi-select. Okay, we will use multi-select option from here. Multi-select, and we will add one text here, add more statuses, and then comma, we will write the logic for adding those multiple statuses. So for that we will say s for s in all statuses. If s is not equal to status mode. comma. Our key would be here extra status. This is for multi-select option to add multiple or additional statuses. And then we will say selected statuses equal to status mode plus extra statuses. So this would be combination of our primary status plus additional status. Okay. So run this query till now. So this is giving error. Okay. At line 47, double inverted comma was missing. So try to run this again. Okay. We need to have colon in front of every if and else if. Now let's run this again. Again here we have missed it. Date time now data. Okay, so it needs to be like this, date time now, and it's date, not data. At line 60, so this is how we are getting all of our order statuses. By default, all is selected. So let's say if I select processing, then it will give you one more option to add more statuses, which is this one. And this would be our multi-select option. So if you'll see here, now processing status has been done, so it will not get shown here. If I say shipped, then I can also add delivered, in transit. So this flexibility, it is given by this code. Okay. Now we will work on our fourth filter, and that would be our region filter. That will come on the right hand side of order status and below this time period. We will implement the same functionality which we have implemented for this order status. Similarly, for the region filter, we will give one select box here. That would be our single select box, and all will be the default selection for that. Okay. Let's say suppose that logistic partner would like to select only particular region. Then from that select box, that partner can select that single region. And if needed, if let's say suppose he wants to add more regions into it, then for that sake we will give one another filter here. And if needed, that partner can add multiple regions from that second filter or second multi-select box. Okay. And that will have ability to select multiple regions. If all is selected here, then we will not display that another filter box here. Okay. So for that, like the way for order status, we have utilized column filter 3. For this region filter, we will utilize column filter 4. And our code would look like this. So here with column filter 4, our drop down will start with all. Okay, that will be our default selection, and plus additional regions that will come like this in that selection box. Then if all is selected, then it will include every region, and it will not need any additional filter. So for that we have if statement. Else, if particular region has been selected or picked, then we will let them add more regions via multi-select option. For that, we will have this else statement. So till now, we will see how these four filters look like. So I'll just remove this part first, and we will run our code that is implementing all of our filters. So this is how our filter will look like. Filter by order status ingestion date. Time period, we will have various selection methods for time filter. Order status, again, selection box. Now we have implemented this customer region. Here it is defaulted to all. Along with that, we have these regions to select. Let's say suppose partner has selected North America. Then if needed, that partner can also select another region, which is Europe, from this box. And here we are giving multi-select option, okay? If not, then he can simply remove it and leave it as it is. If that partner wants all the regions, then he can simply select all, and then that filter will get vanished. So this is how this filters will look like. Now we will move ahead to our important part. So the filter choices which we will have over here, okay, for all these 4 filters. With that we are going to build our where clause from the SQL, okay. For that our code is this one. So every selection from here, that will create our where clause from SQL, okay. So select star from table name where, and then that where clause we will create from these selections. So first it is for date filter, which is this one, time period. So it will start with the date part, and that date part will create our where clause. Here we are implementing if statement, so we will only add a date filter if that user actually selects a date range, okay. What does that mean? Apart from this all time, if that partner will select any one of this selection or any one of this filter, then that will have particular start date or end date, okay. So if I say last 7 days, then my end date would be today's date, and my start date would be today's date minus 7 days, okay. So that would be my start date. So each one of these selection would have start date and end date. So this if statement is for all the selection except all time. Coming back to this, it states date column is not defined because we are yet to implement all this logic. So here, coming back to our code, this if statement is for that. We will add our filter only if we have date range, okay, start date and end date. Then we will create where clause from this section. So we will use between for that, and we will use between with 23:59:59 timestamp, okay, on the end date, so that we can include the entire last day. This will come for date filter. Then for status filter, we can build our status part from this where clause, which would be this order status. We will only add this when or if the user has picked specific statuses and not all, okay. Similarly, if all is not selected and if that particular status, which is from pending to cancel, it has been selected, then only this if statement will execute, and then only this where clause will get created. Here under this if statement, for this where clause, we will convert our list, whatever we will select, pending, process, shipped. So whatever selection has been there, it will convert that list into SQL format, okay. Then we will have, or we can say if we already have date filter present in our where clause from here, then we will add and condition, and then this another query will join this where clause query with and statement. So let's say select star from table name where time period is today and order status is pending and shipped, okay. So these two things, time period and order status, we are joining it with and. Now this region filter, for this region filter, this one customer region, we will implement our where clause. Similarly, again we are checking if the region mode has not, or it is not set to all. That means if that is a particular selection, let's say suppose North America, and then I have selected Europe, okay. So this selection or one more selection, for that we will implement this if condition, and under this if condition we will implement this where clause. Similarly, we will convert our list into our SQL format, and if any previous filter is already, or if any previous filter has already started with where, then we will simply join that where statement with and condition. So for this selection, what would be my condition? If, select star from where time period is today and order status is pending and shipped, and customer region is North America and Europe. So this is how this logic will implement our where clause. And this st divider, it will add one more line like this below this filter section. Okay. So we will run all of our logic now. Now it states that date column is not defined. So the error was we didn't work on this radio button selection. So we need to give date column as either order date or ingestion date, so that the queries which we have implement, that will function as expected. Okay, so for that it has suggested this change. Date column is order date if date type is equal to order date, else it would be ingestion date. So let's keep this change and then try to run this query. Okay, so now this query will function as expected, and according to this, it will give you all the charts which we are going to implement in this part. Okay, now let's move ahead with that, with these charts creation. Now in the next part, we will see how we can cache our data. Then we will create few functions, and under those functions, we will write few queries which will be used further to create our 4 columns. And we are going to create 4 columns here in the below part, and that will get displayed throughout the pages. So for that, the code would look like this. I'll explain you step by step. So our code will start from here. We were done till st divider. Our code is starting here. Okay. So this cache data, this is our decorator. Okay. And this decorator will basically tell our Streamlit app to cache the function's result for 60 seconds. So if in that case, if user interacts with dashboard, but it doesn't change filters, in this case, we can reuse our result, or we can reuse our cache data instead of hitting our Snowflake with the queries again and again. And as a result of this, this will make our dashboard fast. Okay. For this, our first function is df fulfillment. Again, for this, we are utilizing our combined filter, which we have created just above. This function, it will basically answer how well are we delivering orders, broken down by region and customer type. In this, we have this select query. This select query will basically group all the orders by region and segment, and then it will count how many orders were there as delivered, pending, or cancelled, and so on, depending upon this order status. And then it will calculate the fulfillment rate. Once this query gets executed, the result of this query we will get as pandas data frame, so that Streamlit app will be able to display it. So this is our first function, load fulfillment. Then we have our second function, which is load supplier. Again, for this function, we are utilizing our combined filter, and we are caching our data for 60 seconds. So this function, it will answer which suppliers are performing well and which are causing the problems. So this query inside this function, it will basically tell us each supplier's average performance score, their lead time, their on-time rate, and their delay days. This will help us to identify which suppliers to keep, with which suppliers we need to renegotiate, and which suppliers we need to replace. And this pandas data frame, it will return our suppliers performance data to Streamlit app. Then we have our third function. For this, again, we are utilizing combined filter and caching of 60 seconds. This function, it will answer our question, which is our inventory moving fast enough, or is it still sitting idle in our warehouses? So this select query inside it, it will basically give us inventory turnover ratio, which means how many units were ordered divided by average stock level. And higher the ratio, it means our products are getting sold quickly, which is good for our company. And this ratio, if it is lower, which means we are stuck, our products are getting stuck somewhere on the shelves, okay? And we will need to figure it out. And that is not good for our company. And this pandas data frame, it will return our inventory data. Then we have our another function, which is load shipments. Again, we are using combined filter and we are caching our data for 60 seconds. This function, it will answer which shipping carriers deliver on time and which ones are always late. For that, we have this select query. This select query, it will give us the count of on time versus delayed shipment per carrier and per region. So this data will help us to decide if we should switch the carriers for certain routes, or we can keep the same carriers as they are performing as expected. And the data frame, it will return the shipment performance data to our Streamlit app. Then we have another function named as load KPIs, which are again utilizing combined filter and caching the data for 60 seconds. This function, it will answer what's the overall health of our supply chain in one glance, okay? It will return just one row with 4 numbers, and that become our big matrix card at the top. And this function, this select query, it will return single row KPI summary. Then we have function load time series. This function will answer how are the orders, revenue, and delays are changing day by day. Okay, so we will use this to plot our trend lines so that we can see if things are improving or if our things are getting improved or getting worse. And this data frame, it will return our daily aggregated data for our trend charts. For this section, we are actually calling all of our functions which we have created above to load our data. And for each of the function, we are passing the same combined filter so that all of our chart, they will consume only one single SQL query, and that will show the same filtered view for all of our charts. So for that, we are calling all of our 6 functions here. For that, we are passing our combined filter, and we are using data frames to load the result for that particular function. Now, before we try to display anything, we need to check if there is actual data to show or not. So for that, we are implementing this if query. So let's say I have no orders today, okay? Then in that case, this filter for today, it will return 0 value. If it will return 0 value, then in the background, that data frame would be empty. And there is possibility that this code would get crashed because of the 0 data. So to avoid that, to avoid this app from getting crashed, we can throw one error, and that error will say no data available for the selected time period, okay? And then it will stop our app at that point. Then we are creating 4 equal columns across our pages. One column for each KPI card, okay? So for that, we have 4 columns here. First, it will show total orders, that shows volume of business. Then the next one will show total revenue. It will show all the total orders value here with the dollar sign. Then we are displaying fulfillment rate. It would be in percentage. Then we are showing on time rate, okay? So which means what percentage of orders that has arrived with 0 delay days. And then we will have one divider. Now let's run this and we'll check if it is working as expected or not. So see, okay, so for today I haven't run anything. Now my filter is ingestion date. So for today, I haven't ingested any data either in historical or continuous mode. So this filter, it is returning 0 values. For that, it is displaying warning, which we have created here. Now let's say suppose ingestion date, I'll say this week, okay? Okay, so yeah. So for time period this week, for customer region North America and Europe, order status pending and shipped, we are getting this value as this one. We have created these 4 columns in this section, which is displaying total orders, total revenue, fulfillment rate, on-time rate, total revenue. It is getting displayed with $sign. This is with percentage, and this is again with percentage. So let's say suppose we will check this for all. Then this value will get changed. Okay. If I say year to date, then again the value will remain same because I'm recording this project within this week only. So the result for this week and year to date is same only. For today, again it will display, or it will give us the warning which we have set here. And these all 4 columns, they are utilizing the values from the select queries which we have implemented under the functions which we have created here in the above part. We have implemented 6 functions in this above part. Now next, we will move ahead and we will create 4 tabs here. Not 4, we will create 3 tabs here, and under these 3 tabs, we will create different charts. Now we will see how we can create our 3 tabs and we can create different charts under those 3 tabs. Okay. So for that, our code would look like this. I'll explain you step by step. So we are till here, and from here I have pasted this code. What I'll do first, I'll run this and then I'll explain you parallelly along with the charts. So we have these 3 tabs here named as trends, breakdown, and suppliers. On the right hand side, you can see trends, breakdown, and suppliers. We are doing this deliberately so that any business user or logistic partner, if he sees these charts, he should not feel overwhelmed by seeing everything at once. Okay, so for that sake, we are creating these 3 tabs so that that person can go in each tab or in that required tab, and then that person will be able to see required charts or he will be able to see different perspectives in those respective tabs. So first, let's check for tab 1, which is trend. So this is the code for our tab 1. For tab 1, our first chart is our line chart with subheader daily orders. We can see our subheader daily orders here. On the right hand side for this line chart, we can see on the x-axis we have order day, and on the y-axis we have daily orders. The same input we have given here using st.line chart. DFTS, x is order day and y is daily orders. So for these 3 charts under tab 1, we are consuming DFTS data frame. So this DFTS data frame is nothing but this data frame which is coming from this function which we have created, load time series. So output of the SQL query under this function, that we are having under this data frame, and that output we are using under this tab 1 to create these 3 charts. First is daily orders for line chart. This chart, it will basically show us how many orders come under in this Flowbridge company each day. Okay, so spikes, it could mean a promotion has worked, or dips, it could mean we have some problem. Okay, in this way we can analyze this. Then our second chart is this one, which is for daily revenue. For this, we are again utilizing the same data frame, and here we are having area charts. On the x-axis we have order day, on the y-axis we have daily revenue. This chart, it will show us daily revenue similar to the orders but weighted differently by order value. And we are using area chart for this because it would make it easy to see total volume of revenue visually. Then we have our third chart, which is for average delay days, which is this one. We have given our subheader as average delay days, which is getting displayed here. Then we are implementing line chart for this, utilizing same data frame. On the x-axis we have order day, on the y-axis we have average delay. So this chart, it will basically show us the average delay days per day. We want this line going down over the time period because this means that deliveries are getting faster. If it is going up, then something is wrong with our logistic. Next section, we have tab 2. This part, we will now work with tab 2. Now, in this chart, first we will navigate to our second tab, which is breakdown. Under this, first, under this, we are having two columns now, column A and column B, which is nothing but this is column A and this is column B. First, we will work with column A. This is the code for this. Under this column A, we will have orders by region. So this will basically show us which regions generate most of the orders, okay? And it will help us to answer, should we invest more in that particular region or not, okay? Here we are using bar chart. On the x-axis, we can see customer region. On the y-axis, we can see total orders. And we are using data frame DFF. And for this, we are using group by statement and we are grouping it by customer regions and total orders. Now this DFF data frame, which is getting fetched from this load fulfillment function, which is utilizing this custom SQL query, which we have generated using these filters. So this is how we can see orders by region. Now we can see revenue by carrier. For this, we have this column B code. With this chart, this chart will basically shows us which carrier handles most of the revenue. So this is important for the contract negotiations, so that carriers handling more, we can say more, what we can say, more value, no, more amount, those carriers will have more leverage, okay? For that, we have subheader revenue by carrier. Again, here we are using bar chart with carrier as X and total revenue as Y. Now we are using data frame DFD, and for that we are grouping it by carrier and total revenue. And we are using sum aggregation here. So this DFD, this data frame is coming from this load shipments function. So this is how we have these two bar charts under this second tab, which is breakdown, which we have implemented using column A and column B. Now we are creating our third chart under this second tab, which is on time versus delayed by carrier. So for that, we have this subheader. So this chart, it will put on time and delayed shipments on top of each other like stacked bar chart. And if carrier has way more delayed than on time, then that's the problem we need to address, okay? So for this, we will sum both the on time and delayed counts per carrier. And then we will use bar charts. On the bar chart, we have carrier as X. And on the y-axis, we are having this stacked bar chart. So if I'll hover over on this, for that particular carrier, now in this case, our carrier is this DB carrier, which has on-time shipments 44 and which has delayed shipments 4. This DHL carrier, it has on-time shipments 48 and delayed 11. Here for FedEx, on-time is 46 and delayed is 5. So this is how we can check on-time versus delayed carrier. So let's say suppose here delayed carriers are more than on time, then that's the point of concern. We need to check what's exactly happening with that respective carrier, okay? So this is how this chart will help us to analyze further things. Now we have next bar chart here, which is this one. For this, our subheader is inventory turnover by category. So this chart, it will basically show us the inventory turnover ratio for each of the product category. So higher the turnover, This means that product sells quickly, which is good. That means we are not overstocking. If this turnover is low, this means that our product is sitting in our warehouse, which is bad because our capital is tied up by doing nothing, okay, for that respective product. So to check that, we can use this and or we can visualize this bar chart, which is inventory turnover by category. On the x-axis, we have category. On the y-axis, we have inventory turnover ratio. For this, we are utilizing this DFI, and DFI means load inventory function, which we have created above using combined filter. So this DFI output we will utilize to create this inventory turnover by category bar chart. For this, with this logic, we will average our turnover ratio across all warehouses for each of the category. This is how this second tab will look like. Now switching back to third tab, which is suppliers. For this, our code will start from here, okay, with tab 3, and then complete logic from here we have written here. So our first is supplier scorecard. We can see our subheader here, which is supplier scorecard. First, first what will happen here, we are showing this table with key metrics for each of the supplier. So this is like our report card, okay. At one glance, you will be able to see who is good and who is not. So this supplier card, if you'll see, we are having supplier name. For that supplier name, supplier country, what are their total orders, what's their average performance, what's their on-time percentage rate, and what's their average lead days. So by looking at this supplier card, you will get to know which supplier is performing how. And accordingly, you can decide what action you need to take with that respective supplier. So for that, the logic would look like this. For this, we are utilizing this data frame, which is DFS. DFS is nothing but load suppliers function, which we have created using combined filter. Coming back to this third tab, here we have given our logic. So with this logic, we will only show the most important columns and not everything. And I have decided these are the important columns which I would like to display. So I am displaying those columns in this chart. And this will make our table stretch to fill full page width. Okay, so for that I have given use container width equal to true, and I'm saying hide index is equal to true. This will hide the default 0, 1, 2, 3 row numbers on the left hand side, which is from here. Okay, so to hide those indexes, I have given hide index true, and for this I have said user container width equal to true. Now our last chart, which is this performance score versus on-time rate. For this, our logic looks like this. For this, again, we have used same data frame, which is DFS, which we have used for this scorecard. This chart, it will compare each supplier's internal performance score against their actual on-time delivery rate. Okay. If there is a big gap between these two, it means that either our scoring system is broken or supplier is gaming their matrices. Okay. So ideally, both the bars should be of roughly same value or same height with each supplier. Okay. For that, we are using this bar chart. In our case, this is stacked bar chart. We are setting our supplier name as index on x-axis, and we are plotting both the matrices as bars. Okay, so this would be our stacked bar chart. So for this, let's see. This is our supplier Asia MFG CO. For this, on-time percentage rate is 83.3 and average performance rate is 76.8. For fast supply, on time is 85. This average is 88. Here, global parts, on time is 84. Average performance is 82.4, and so on. So for these suppliers, we can see that on time percentage rate and average performance score, their values, these both values are around same only, like 83.3 or 76.8, 85.11 or 88.2. So this means that this is working same. And this is the caption which I have given, st.caption, and then you can enter the text which you would like to display. That will get displayed like this for each of the tabs. Okay. So this is how our complete app looks like. Before starting continuous ingestion into our production container, what we will do, first we will deploy our Streamlit app. Okay. For that, to deploy it, we have this option given. Click on this deploy. You need to give app name here. So let's say in my case, I'll give Flowbridge Supply Chain Dashboard. Then app ID, this is again optional. You can give if you need or if you want. Let's say suppose I'll give the same. It says invalid characters. Consider enclosing double quotes. So in this case, we have these spaces here. So that's why it is throwing that error. If you want to move ahead with that, you can give double inverted. So these special characters, those are also not acceptable. So let's see if I remove it. Okay. And then I'll just make everything lowercase. You can give double quotes also if you'd like to move ahead with whatever we have given at the start. Supplies, Flowbridge supply chain. Okay. Now app location you need to mention. Okay. So for that you need to select database and schema. So for this, what I'll do, I'll select production database and schema. I'll have serving schema. Okay. Compute pool. We have one compute pool now, which I'll select that default one. Now query warehouse. So here I'll select Flowbridge Analytics warehouse. Okay. If you remember, we have created two warehouses, pipeline and analytics. Pipeline was for all the work which we have done for data cleaning and data transformation. And analytics we have utilized for secure views creations under this serving layer. And for this app also, we are going to utilize this analytics warehouse. So make sure that you are selecting the correct warehouse. And then I'll say deploy. Now let's wait. Okay, so it says app deployed successfully. Now if I click on open app, it is taking time to install all the dependencies and it will start our warehouse and this section. Now after this app deployment, I have gotten one error which states timestamp 7 days. It is not getting recognized by this Streamlit app. I have taken help of Cortex code and Cortex code has given me the answer for what it is getting error. So if we'll check our code, we have given this else if statement, right? So let's say suppose you are on this screen and now you need to navigate back to your code. For that you need to click on edit. Once you will click on edit, it will show you all the code which we have written for this app. Now if we'll come here, we have given this if and else if statements, right? In this section it is saying that this week or last 7 days, 14 days, we are using time delta. But with that, we are just mentioning days, okay, 7 days, or this days is equal to 30, 90, and so on. So because of that only 7 days is getting passed to our SQL query instead of getting actual date, okay. So to fix this, we need to change these lines. And instead of just saying like for this week, just instead of just saying time delta and days, we will say today minus that time delta and days logic. Again for 7 days, instead of saying time delta days 7, We will say today minus time delta with date 7. Okay, so this is how this part will get changed. So here it will ask you, would you like to navigate back to workspace and make this edit? Let's say if I'll say yes, then let's check if Cortex code navigates back to this and make changes. If I'll come down to our main code. Okay. So now you can see red highlight means that was wrong logic, and which is corrected by this green highlighted part. Okay. So here if I'll say keep all in file. Now this change has been done by the help of Cortex code. I'll run this again. Run it successful. Now what I'll do, I'll deploy this again with the same dashboard name and all the same changes. I'll say deploy. It says an app already exists at this location. Would you like to replace it? I'll say yes, replace. Okay, and again I'll open this app. This initial process, it will always take some time to load everything. It means around roughly 30 to 60 seconds. Now we can see that our app, it is getting, or it is showing the results as expected. If I'll switch back to ingestion date, then we can see our trends, those are changed now. Breakdown, it is also changed. So this is how our complete dashboard or Streamlit app will look like. Now coming back to our workspace, okay. If I'll come back to my workspace, if you'll see on this left hand side under untitled, we have this Streamlit folder, which is .streamlit. Under this, we have this TOML, YML, and PY files, though you can see A as in added, which is added by Snowflake. We'll see this YML file. It looks like this, which have type, main file. Then we have artifacts, identifier. Under identifiers, it has given database name, schema name, our app name, which we have given at the time of deployment, then what's the title of our dashboard, which query which we have given, and that was our analytics warehouse, compute pool which we have selected, run mode, and executor as owner. So this information is under YML file. If we'll check this TOML file, then it will just add description of our Streamlit app or dashboard which we have created under this Streamlit app. So this information you will get under this TOML file, but the main logic which is needed to create this app, that main logic, it will come under this .py file. Now again, switching back to changes, we have done these changes under this feature 10 branch, okay, under resume and verify. First we will push this to our Git account. I'll give description as Streamlit app development completed, and now push this to our Git account. Let's wait till we get success message over here. It is completed. Now switching back to our Git. Let me refresh this. Now I can see I have recent pushes for this feature branch. Click on compare and pull request. Make sure to change base from dev to main. Sorry, from main to dev. Create pull request. It will check, and then If no conflicts, merge pull request, confirm merge. Our branch has been merged to dev. Now coming back to our code, what I'll do, first let me close unnecessary tabs, and then I'll just duplicate this one tab. So here, okay, so under first tab, I'll close everything and I'll keep our last SQL file, which is resume and verify. And under another tab, I'll open my Streamlit app, okay? I'll run this and I'll just minimize all the codes so that we can see our dashboard. Okay, so now I have two tabs open for Snowflake. First is this resume and verify, where we will resume everything and then we will keep verifying our SQL statement. As of now, our SQL query is returning these values, okay? Okay, so this is returning these values. If you remember, for the production container, this container, we have ingested 3 files. These are JSON files because we have ran historical mode from our VS Code, okay? The mode was historical. So because of that, we have gotten 3 files under this prod container, which we fetched into Snowflake, use Snowflake via Snowpipe. Then we have performed data cleaning and transformations. Then we have created secured views and shared those views with our logistic partners. Then we have created our Streamlit app and we have written code for that, okay? So till now we have 300 records and we have these values under each of the tables which we have created and under this cleaning and transformation tab. Now this app, it is displaying the data for these 300 records, okay? Order date and ingestion date. Now we are going to run our continuous mode from this VS Code, and then we will see how we can get new files here after these 3 files. And then before this, we will be resuming everything so that this Snowpipe will run and we will get updated records in these tables. So we will keep cross verifying our table values by running or rerunning this SQL query. And then once we get all the values for our continuous mode under these tables, then we will check if our tab is getting updated, if our Streamlit app is getting updated correctly or not. So you have two options. You can keep loading data on this data so that your values will start getting increased from this 300, okay? Either you can keep these 300 values into your tables as it is and you can keep ingesting data so that these values will get increased, or you can truncate all these values, make each and every table to 0, and then you can cross verify from scratch, okay? You can select any one of the option. As of now, I'll move ahead with second option and I'll truncate these values. I would like to start from scratch, okay? So for this, to truncate, I'll take help of Cortex code instead of writing everything. What I'll do, I'll say make sure that you say truncate and not drop, okay? I'll say, can you truncate all the table values as I would like to verify data for continuous ingestion. From the scratch. And for the better understanding for Cortex code, I'll just mention all the table names. Enter. We will say allow to each of the truncation. If you see, first it has truncated aggregation base, then raw orders, average inventory turnover, then aggregation order fulfillment, supplier performance, STG orders, dim product, dim shipment, dim supplier, dim warehouse, packed orders, dead letter, dim customer, supplier delays, shipment delays, not supplier delays. I'll say check supplier. Okay. Now it says for the dynamic tables, we can't perform drop for that. Okay. So for that, it has automatically said alter query. Okay. And you need to say refresh. So for dynamic tables, it will give you alter queries. Click allow. Then the second one, then aggregation based dynamic table, then order fulfillment, shipment delays. Now it is verifying row counts. It has truncated all our 14 tables. But let's check these views now. I'm not sure. Okay. So it has truncated all the views too. And now let's check our select query. Now we can see that all of our tables has 0 values. Okay. Now if I'll come back to my Streamlit app, I'll click on refresh data. Now if you'll see here, it states no data available for this selected time period because we have truncated everything and we don't have any data present into our tables. Hence, it is displaying no data available. Okay, so this is as expected and it has given us warning error instead of crashing our Streamlit app. Now coming back here, first we will resume everything. Select sysadmin role, select warehouse, alter our pipe, run this, select pipe status. Now our pipe is running. Alter our both the tasks. We need to resume our alerts if anything fails, then we need email to get triggered to our respective email address. So make sure it will get resumed. So if you remember, we have set alerts in case of failures, okay, and not for the success. Because if you will keep triggering emails for the success, and if you are running your pipeline into continuous mode, then imagine getting emails at every minute into your email box. Okay, so that would be very complex. So to avoid that, we are just setting our alerts in case of failures. Resume all of our dynamic tables. And now we are back to our select query. So everything is 0, 0, 0, 0. Okay. Now from here, these files we have worked on. Okay. So ideally our Snowpipe should avoid, like it should not pick these files. Okay. And it needs to pick the files which we are going to insert because those are completely new files and on which we haven't worked. Okay. Now coming back to our VS Code, if you'll see, I can use same terminal or new terminal. It's up to you. Now our command to run this is this one. Environment is production and mode is continuous. So I'll paste this command here and I'll hit enter. Now let's check. Okay. So it has uploaded file 1 and if you'll see here next file in 30 seconds. Okay. And if you'd like to stop at any point, you need to press Ctrl plus C to stop. Okay. So if I'll come back to my ADLS, now if you'll see for today's date, we have ingested first file. Then it has ingested second file. If I'll come back to my ADLS Gen2, we have now second file. Let's check our SQL query, and each file has 100 records. So our Snowpipe, it has ingested first file as of now because raw orders we have 100 records. Now it will load second file also. We need to wait for that. Here, if you'll see, raw data only has 100 records and STG orders has 92 records. Okay, means that our logic which we have implemented for bronze, silver, and gold, that is our data is flowing through that. Okay, and it will keep updating as data passes through each of the record. Now it states we have error at line 47. So what I have done, I have just selected this part. Okay, this part, and then I have clicked on run button. Okay, so in this case, whatever part I have selected, that will get run, which is not correct. I need to run entire query. So either select entire query or just place this cursor somewhere without selecting any keyword here or word here or text here, and then click on run. In that case, it will run our code. Okay, by the time we have seen, we have 600 records now because our 6 files has been inserted. I'll say Control C because 6 files are enough for our cross verification. If you would like, you can keep this mode running continuously, but you need to also consider that warehouses which we have created that are of extra small size, and we are working in free tier. So make sure that you are not consuming a lot of credits. So for this project sake, I'll just keep these as of now 6 files. Coming back to ADLS, 4, 5, 6. We have 6 files here. Till now, okay, again I have done the same mistake. 600 records has been inserted, and then next tables are running now. Okay, app, it will not show data because we haven't reached till serving layer. So if you would like to check from Snow site, you can check it from here. Go to catalog, database explorer, where we need to verify our FlowBridge database. If you'll see bronze layer, if you'll check this pipe, copy history, you can check copy history from here, or you can cross verify your data from here along with file name. We need to have 6 files, 1, 2, 3, 4, 5, and 6. Okay, now I hope it is 6, 8, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, which is 8, 4, 5, and then 6. Okay. Stages. This one was our prod stage. Stage files. Just refresh these. You can see 6 files for today's date. Tables, raw orders, data preview. We have 600 records. Now, silver schema. We can cross verify table values for this from this layer, or streams we can check. Stream is active. This stream is also active. Procedures. We have tasks, 2 tasks which we have activated and which are in starting mode. Now coming back to our SQL query. So now we can see that our data has not moved further. Okay, here STG orders mean bronze, dead letter means bronze. So our data came till bronze layer, but silver and gold layer didn't work because we don't have any data for these rest of the tables. Now we need to make one small change here. By mistake, I have misspelled one stored procedure name. So if you'll come to 8th file, dev to production, SQL, where we have recreated our stored procedure. So first stored procedure name, it was SP bronze to silver, and then our stored procedure name was silver to star, okay? And when we created task, here I have given incorrect name. So this SP bronze to silver, and then I have mentioned name as SP silver to star. So if I'll come to this snow side, SP silver to star and SP bronze to silver. So this part I need to correct it, okay? So it needs to be SP silver to star. And then I'll recreate this task again. Now let's verify our query again. We need to do one more change here. So come to this second file, bronze.sql. Here in this section where we are creating our pipe, under this copy into section, make sure that you are entering ingested at from, and then you are mentioning current timestamp here, okay? So this is one change you need to do for this pipe creation. And then the second change, go to your 8th file, which is dev to prod. Here also, and make sure that after doing this bronze change, right, recreate this pipe again, okay? So create or replace, it would recreate your pipe again. If in case you would have written create pipe if not exist, then remove that if not exist and say create or replace pipe and then recreate this pipe, okay? So this pipe was for dev environment. Now coming back to our 8th file, here also we have created another pipe for our production environment, this one. Make sure that under copy into you are giving ingested at, and for ingested at, make sure that we are inserting our current timestamp, okay? And then let's run this query again. Now we can see we are getting expected results into our tables. If you would like to verify each one of the table, then you can select that table and check the entries. I'll just verify if we are getting data into our views or not, as these views will get shared with our logistic partners. So we are getting as expected entries into our secure views. Now coming back to our dashboard, once you click on this refresh button, it will give you updated records here. Now we can see that for time period today, we are able to see some values here. Right now filter has been set on order date. So we have 7 total orders for which order date is today's date. So if I'll say ingestion date today, then it will give you updated records. And for this period, if you'll see, those all 600 records we have inserted for today, okay? So for that, ingestion date for all those records would be today's date. So that records would get displayed here. If you'll come down, order date, total revenue, fulfillment rate, on time rate, we can see. Along with that, we can see trends for daily orders, daily revenue over this time series. If you'll hover over on any one of these data, then it will show you order day and daily orders for that respective day. Similarly, we can see daily revenues. Then we can see average delay days, where we are displaying order day by average delay. Here we can see breakdown of order by region, revenue by carrier, along with that information. Same for on time versus delayed by carrier. Then we have inventory turnover by category. Suppliers, we can see all our suppliers with their updated records, then performance score and on time rate for particular suppliers. So this is how our information will get displayed. So let's say here, if I'll say order status pending, and I'll choose one more status as, let's say, shipped, okay? So this is how it will update all of your records accordingly. Now let's say we will select customer region as North America, and we will select one more region as Europe. So accordingly, we can see that our values are getting changed. Okay, right now here orders by region, as we have selected two regions here, North America and Europe, those are getting displayed here. And revenue by carrier, now it will shows the value for only these two selected regions and for these two order statuses. Okay, suppliers value, that also will get updated, and trends, that will also get changed accordingly. Okay, so this is how our dashboard will work. We have share button here. If in case you would like to share this dashboard, you can add a role to share with, add respective role here, and then you can copy that link from here. You can select either for app builder or for app viewers. Okay, and once you will copy that link, click on done, and you can share that link along with the logistic partners or the business user, whoever is at the receiver end. So this is how you can share your Streamlit app. Now, so far we are done with our coding part in Snowflake, and we have pushed all of our work into our Git account. Okay, let's cross verify it once if we have any changes here. Now, so far so good. Our dashboard is also ready. Our complete project is ready here. If in case you would like to again run this into continuous mode, you can keep running it and keep checking the values if they are getting updated correctly or not, and if our dashboard is getting updated accordingly or not. Now we are at the last part. For that, we'll come to Git account. Here now we can see that all of our code, if you'll see here, main branch, we don't have anything apart from this README file. Okay, and that README file, it got created when we created this repository. If you'll see here, you will be able to see all the branches, feature branches in this. If you'll come to dev, you will be able to see all the SQL files here which we have created which we have created under these feature files, and then we pushed it to dev. Okay, now we are going to push our dev code into main code. Okay, sorry, we are going to push our dev repository code from dev repository to main repository. So for that, what we will do now, if you'll come under this pull request, you will be able to see dev had recent pushes about 1 hour ago. Okay, click on that, compare and pull request. Now here our comparison would be between dev to main. Okay, and here you can add the title. Let's say I'll add the title as release. Low Bridge project go live. And here under the description, I can add description too. Let's say I'll say all the development and testing completed for Low Bridge company. Code is ready to move from dev to prod branch, or let's say environment. I'll keep it as branch only. Now create pull request. So this is what it will look like. Whatever merges we had done, it will show you all the details here. Click on merge pull request, confirm merge. And we have merged all of our changes or all of our development from dev to broad. And in this way, we can say that our project is now into go live mode. Here, if you'll select this main branch, now everything will look under this main branch. So this is how we have completed our project, and this one was our last step to merge our code from dev to prod. In this way, we came to the end of this project. If you remember, initially we opened our VS Code. In that VS Code, we have Python generator file. Then under Azure, we have created ADLS Gen2 account. For data ingestion, we have decided that we will have two modes. One is historical and another one is continuous, and we will keep inserting data for both of the environments, dev environment and production environment. For that sake, under ADLS, we had two folders here, one for development and another one for production. Then, with the help of Snowpipe, along with that Snowpipe, storage queue and event grid, we started ingesting our data into Snowflake. Under Snowflake, first was our bronze layer. So after data ingestion with Snowpipe, we created external stage here, and then we created our transient table here. With that, we stored our raw data which we are getting with the help of Snowpipe from ADLS. Okay, so these JSON files we are converting into tables, and this will be our raw table where we will get our data as it is. Then under silver layer, we had two stages here. Stage 1, we created streams, then we created tasks, we created procedures, stored procedures, then we created standard tables, and here we have cleaned our data, and then we have moved our clean data into one table and bad records into another table, and this table will get monitored by our operations team. Then under silver stage 2, again we have implemented streams, then tasks, then stored procedures, then standard tables, and with the help of this we have created our star schema. Then under gold layer, we have seen implementation of dynamic tables. For that, we have created one base table, and then with the help of these base table, we have created 4 dynamic tables. Then under serving layer, we have created 4 secure views, and then we have seen how we can give access of these secure views to logistic partners by creating one managed account, and that managed account was reader's account, and we have seen from this reader's account how that logistic partner can access or can get data of these secure views. Then we created one Streamlit app, and we have seen and we have implemented many of the filters. Then we have implemented charts, columns, tables. So basically we have seen many of the things while creating this Streamlit app using Python. And then we have seen how this Streamlit app gets updated once you keep inserting data from this VS Code into ADLS, then how this data pipeline works on that, and how this data gets updated into this Streamlit app. And to monitor everything, we have implemented one alert with multiple functionalities into it, and those all will be in case of failures only. So if in case Snowpipe fails, or if in case any of these tasks fails, then in that case it will trigger one failure mail to that respective person or respective data engineer or data analyst, so that person will get notification, and then he will see or he will look into this data pipeline. And everything which we have done, we have done this development into development environment. Then we have seen how we can move our data using our copy cloning, zero copy cloning, and then how we can, in this copy cloning, we have seen which objects we can clone directly and which objects which we need to recreate. Okay, so for that we have seen this method, and for the version control we have implemented or we have used Git repository, and we have seen how we can create our dev branch. Under dev branch, how we can create our feature branch. Then how we can push our code from dev to feature. And at the end, we have seen how we can push our all the files from dev to production for the go live purpose. So this is how our complete project looks like. So if you have liked this project, then please like this tutorial or like this video. And that's it for the day. Thank you for watching this tutorial and see you in the next one. Till then, keep crunching the data. Have a nice day.